Hello, my name is Shailesh, and the topic of my thesis is accelerometer sensor and sensor data fusion for single phase flow experiments to determine the type of flow and the flow velocity. The main aim of this thesis is to use the accelerometer sensor data, that is the vibration data, to determine what kind of material is flowing inside the pipe, whether it is water, oil, or gas, and estimate its flow velocity using machine learning. This is the workflow which is carried in this thesis. The single phase flow experiments are performed on Equinor rig and USN rig, data collection, spectral analysis, and all these steps are followed. The position of three accelerometer sensor data which is used in this thesis is this one, and this one. First of all, the FFT plots and power spectrum density plots are studied for each water experiments to see the range of the dominating frequencies so that it is easier for us to design the filter. Also for designing the filter, the frequency response of accelerometer sensor is studied, and depending upon that, this filter range was selected. I will fast forward through the plot. To make a real-time system, it was necessary to train the model based on 1 second of accelerometer signal. So the signal was split with 1 second duration with 50% overlap. In feature engineering, in total 26 features were used, and the features can be classified in these three categories. The name of the features are not revealed here to maintain the confidentiality of this report. Training data and test data are manually separated, and these 6 experiments are kept aside to test the trained model. The table here shows the performance of different classification model which were trained and the different type of inputs which were given to that model and the corresponding accuracies of that model. One of the classification model details. Here the inputs is three features of accelerometer channel 1. This table showcases the different regression models and their performances. We can see the input given to that model and the RMSE values. The lower the RMSU is the better. Here we can see the overview of the usage of the models developed here. The output of the classification model acts as one of the important inputs to the prediction model. Inside the MATLAB Live Editor, we can see the instantaneous result of the prediction models of the three classification models which are trained. We can see the original category is oil, and these three classification models predicted the category as oil, and a random row was given as an input. Here, this Simulink structure showcases the instantaneous results of classification model. By turning the knob, we're basically giving three inputs to that model, and we can see the corresponding output. This table shows the test data and the true flow and the predicted flow rate by the models. And here is the corresponding accuracy. Some of the models perform very good and gave promising results in order to continue the development. So the conclusion of this thesis is accelerometer channel sensor data can be utilized to expand or further study the multi-phase flow because different flow types generate different vibration profiles, and this sensor can be further extract and improved to get accurate flow type in multi-phase as well.